The next type of distribution that we're going to look at is a uniform distribution. You'll see here that it has a shape essentially like a box or a rectangle. It isn't peaked in the middle like a normal distribution. It isn't bowed in the middle like an exponential distribution. In fact, it's flat all the way across. So the main characteristic of this normal distribution is that there's an equal probability, there's an equal chance of landing at any point within the range from the lowest possible value to the highest possible value. Because of that fact, we don't even have a calculator here for this in StatCrunch. If you go to the Stat button and Calculators, you'll see we've got the exponential distribution, we've got the normal distribution, but uniform is not up there. That's because it's really pretty straightforward to compute probabilities for the uniform distribution. There's an equal chance of everything. So, let's say this. Let's say that we have a soft drink bottling firm, and they are bottling 12-ounce bottles of soft drinks. So the mean, right in the center of our distribution, is 12 ounces. But there's always some tolerance, some possibility for error with our bottling machine. And so any single bottle that you might get probably isn't going to have exactly 12 ounces. It might be 12.03. It might be 11.9526835. You don't know, but it's going to be close, but it's probably not going to be exactly 12. So our soft drink bottler has figured out that this dispensing machine dispenses a uniform distribution that ranges from 11.7 to 12.3. And 12 ounces, the amount that's really supposed to be in that bottle, is the mean. It's right in the center there. But for any given bottle, it actually has an equal chance of having anywhere from 11.7 ounces up to 12.3 ounces in that bottle. Let's say that we wanted to find the probability of being at 11.8 ounces or less. So 11.8 ounces would be about right there. And we're looking for the probability of being between 11.7 and 11.8. Well, that probability is going to be represented by a fraction. And the numerator of that fraction is going to be the distance between, or within our range here. Our range goes from 11.7 to 11.8. So the distance that's within that range is simply 0.1. The denominator of our fraction is the distance between our minimum value and our maximum value. And the distance from 11.7 to 12.3 is a difference of 0.6. So the probability that we have a given bottle that has 11.8 ounces or less is going to be 0.1 divided by 0.6. If we divide that out, that's going to come out to be right at 17%. What if we wanted to find the probability of being 12 ounces or more? We'll use the same process. Okay? How much is going to be in our numerator? Well, it's the amount that's within the range that we're looking for. So from 12 to 12.3 is a distance of 0.3. Our denominator is still the entire distance from 11.7 to 12.3, so 0.6. 3 over 6 gives us 50%. There's a 50% probability that it will be greater than 12, or between 12 and 12.3. I'm going to leave that up there. I want to take a look at one other option here, because we've looked at one at the lower end of the spectrum, we've looked at one at the top end of the spectrum. How about if we want to find the probability of being between two values in the middle? What if we wanted to know the probability of being between 11.9, right here, and 12.2? That's going to be this area here. We do it the exact same way. The distance from 11.9 to 12.2 is 0.3. Our overall distance from 11.7 to 12.3 is 0.6. Again, 50% of all the values will fall between 11.9 and 12.2. Well, let's go back to that previous example that we had. And let's say that we're interested in bottles that have more than 12 ounces in there. So since 12.3 is our max, that means it's going to be somewhere between 12 and 12.3. And we've seen that there is in fact a 50% probability, or 0.5 probability, that any given bottle is going to have between 12 and 12.3 ounces. Well, let's think back to what we already learned about probability back in chapter 3. What if we wanted to find out the probability that 5 bottles in a row would have more than 12 ounces? We know that the probability that that first bottle is going to be between 12 and 12.3 is 0.5. Probability for the second one is 0.5. Probability for the third and the fourth and the fifth bottles, they're all 0.5. And in order to have 5 bottles in a row that all have between 12 and 12.3 ounces, the first one would have to happen, and the second, and the third, and the fourth, and the fifth. And whenever we see that and we're dealing with probability, we know that that means we're going to have to multiply those probabilities together. So we end up with 0.5 to the 5th power. And we can compute that here right quick. 0.5 multiplied by itself to the 5th power. And we end up with a probability of right at 3%. 0.03125, or a 3% probability that we're going to have 5 bottles in a row with more soft drink in there than is actually reported on the bottle.